B12 shock after 60, hidden vitamin danger for seniors. Hello everyone. Stop scrolling. This message can change your life. Hope you all are doing well. This video is inspired by the research and public talks of Dr. Barbara O'Neill. Imagine this. A single vitamin, something most people assume is always beneficial, quietly changing the fate of your nerves after age 60. Not all vitamin B12 is equal, and in the aging brain and body, one form can subtly shape whether your nerves heal, fade, or silently deteriorate. Tonight, let's explore this with curiosity, humility, and care for the remarkable biology that carries us through life. Vitamin B12 is often spoken of as a simple vitamin, but in reality, it behaves more like a molecular architect working quietly inside the nervous system. Every thought, every movement, every sensation depends on tiny electrical signals traveling through nerves, and those nerves rely on a protective layer called myelin to function smoothly. Vitamin B12 is essential for building and maintaining that myelin, acting as a cofactor in the biochemical pathways that keep nerve fibers insulated and efficient. When B12 is insufficient, the insulation thins, the signals weaken, and the nervous system begins to resemble a network of frayed wires. After age 60, this process becomes more delicate because the body's ability to absorb B12 naturally declines as stomach acid production decreases and intrinsic factor, a protein needed for absorption, becomes less active. Many older adults assume that taking any B12 supplement will solve this, yet the form of B12 matters in subtle and powerful ways. Cyanocobalamin, the most widely used and inexpensive form, is synthetic and must be converted by the liver into active forms before the body can use it. In younger, healthy individuals, this conversion is usually efficient, but in older adults, especially those with liver stress, kidney impairment, or genetic variations, this conversion can be slower or incomplete. This means the vitamin may circulate without fully supporting nerve repair, and in some metabolic contexts, the breakdown products may add an extra burden to detoxification pathways already taxed by aging and environmental exposures. Scientific curiosity is now exploring whether prolonged reliance on less bioavailable forms could contribute to persistent nerve symptoms, particularly in people with diabetes, vascular disease, or chronic inflammation. This does not mean cyanocobalamin is inherently dangerous, but it invites a more nuanced view of nutrition, one where molecular form and individual biology intersect. Aging bodies are not simply older versions of younger ones. They are systems with altered priorities, altered capacities, and heightened sensitivity to biochemical details. In that sense, understanding how a single vitamin form interacts with nerve health becomes a window into a larger truth about aging. Precision matters, and what once worked effortlessly may require a more thoughtful approach as the years advance. There are forms of vitamin B12 that the body recognizes immediately, like keys that fit perfectly into biological locks without the need for reshaping. Methylcobalamin and adenosylcobalamin are these active forms, and they participate directly in the cellular choreography that sustains nerve health. Methylcobalamin, in particular, plays a central role in methylation, a fundamental biochemical process that influences how genes are expressed, how toxins are cleared, and how neurotransmitters are synthesized. In younger bodies, methylation often runs smoothly, but with age, this process can slow, creating subtle imbalances that ripple through the nervous system. When methylation falters, the repair of nerve tissue becomes less efficient, and the brain's chemical messaging can become less stable. Providing methylcobalamin is like supplying a skilled worker directly to the site, rather than sending raw materials and hoping they will be assembled correctly. This is why researchers have observed that methylcobalamin may be more effective in supporting nerve regeneration, particularly in peripheral neuropathy, where tingling, numbness, and burning sensations signal distressed nerve fibers. In clinical contexts, methylcobalamin has shown promise in improving nerve conduction and reducing symptoms, suggesting that the form of B12 can influence not just blood levels, but functional outcomes. Adenosylcobalamin, meanwhile, works within mitochondria, the energy centers of cells, supporting metabolic pathways that fuel nerve cells and maintain their resilience. Aging neurons are energy-hungry and vulnerable to metabolic stress, and providing an active form of B12 that participates directly in mitochondrial function can be seen as reinforcing the power supply of the nervous system. This perspective reframes supplementation from a generic habit into a targeted biological intervention. It also highlights a philosophical point. The body is not merely a container for nutrients, but an intelligent system that responds differently depending on how information is delivered at the molecular level. When older adults choose an active form of B12, they are not just adding a vitamin. They are participating in a precise dialogue with their cells, offering molecules that speak the body's biochemical language fluently and efficiently, especially when translation mechanisms have become less reliable with time. Beyond the chemistry of supplements lies a deeper lesson about how aging reshapes the conversation between the body and its environment. After 60, the human organism becomes more discerning, more sensitive to subtle shifts in nutrients, hormones, and cellular signals. Vitamin B12 becomes a symbol of this precision. It is not only about how much you take, but how your body receives it, transforms it, and uses it in the quiet labor of maintaining nerves, cognition, and vitality. Absorption begins in the stomach, where acid releases B12 from food, and intrinsic factor escorts it through the intestine into the bloodstream. With age, both acid and intrinsic factor often decline, and medications like proton pump inhibitors or metformin can further reduce absorption. This means that even a diet rich in B12 may not guarantee adequate levels, and symptoms like tingling in the hands, numbness in the feet, balance problems, fatigue, or subtle memory changes may appear gradually, almost invisibly, until they become impossible to ignore. Testing B12 levels becomes an act of curiosity and self-respect, a way of asking the body how it is coping with time. Yet numbers alone do not tell the whole story. Functional markers, genetic variations in methylation pathways, and the health of the gut microbiome all shape how B12 supports nerve tissue. Chronic inflammation, vascular disease, and oxidative stress can make nerves more vulnerable, so that even minor deficiencies have amplified effects. This transforms nutrition into a systems-level inquiry, where lifestyle, sleep, diet, and mental health intersect with micronutrients. When older adults choose to adjust their nutrition with awareness, they participate in a quiet form of scientific practice, experimenting with the conditions that allow their biology to function with grace. The philosophical dimension emerges here. Aging is not merely decline, but an invitation to precision, to listening, to collaboration with the body's evolving needs. Vitamin B12, in this light, is more than a supplement. It is a reminder that health is a dialogue between molecules and meaning, between scientific insight and lived experience, between the measurable and the deeply human desire to remain connected to sensation, movement, memory, and identity as the years continue to unfold.